Okay, so we're going to do our 1.3 day 3 notes. We're going to talk about piecewise functions. We're going to do domain and range and graph them, and then we're going to learn to write absolute value functions as a piecewise defined function. All right, so first we're just going to talk about evaluating at the given values. Okay, so piecewise functions have more than one function. That's why they're called piecewise. So for x is less than 0, then I have this graph. And then for x is greater than or equal to 0, I have this graph. All right, so I have to look and see what x values I have to know which functions I need to plug them into. So for f of -2, well, -2 is less than 0, so I'm going to be plugging it into this function. Okay, so then that gives me -1. Okay. For f of 0, well, I have to find the one that's equal to 0. So that would be right here, this one. F of 0. Okay. So then I get 7. And then for f of 3, I also want this one. So f of 3 that equals 19. Okay, 3 is greater than 0, so I know I want the bottom one. All right, same thing. All right, so this time I have domain values that can be anything but 3. So this top one says anything but 3. And then the bottom one, if it is 3, then I have the y value of 6. Okay, so for f of 5, well, 5 is not 3, so I'm going to plug that in to the top. So right here. Okay. So 25 minus 9 is 16. 5 minus 3 is 2. And then 16 divided by 2 is 8. Okay. Feel free to pause this at any time, too, if you want to work it out on your own. Okay, for f of 0, well, that's not 3, so I still want the top. So that's -9 over -3, which is 3. And f of 3. So if f of 3, if x equals 3, then f of x equals 6. Or in other words, y is 6. So if x is 3, and y is 6. Okay, so evaluating is not too difficult. Use your domain values here to know which function to plug it into. All right, let's look at graph. So I have two functions. The top one is linear. And if I think about transformations with this, so my parent function is f of x equals x, and then a +2 at the end would be a vertical shift of 2. Okay. And then this is for the values where x is less than or equal to 1. So you can plug in points if you want. So let's find where f of 1 is, because that's where it's equal to. So that would give me 3. So f of 1 is 3. So I have the point 1, 3. For my parent function, I have these 3 points, and then they shift up 2. So I'm here, and here also. Okay. You also could use slope and y-intercept. So y equals mx plus b. So my slope is 1, and my y-intercept is 0, 2. So I go to 0, 2, and I go over 1, up 1, or down 1, left 1. But I need to make sure I have the part of my graph that my domain specifies. So x is less than or equal to 1. So where x is 1, f is 3, f of x is 3. And so then I want less than, which would be to the left. So I want this side, not these, so I erase those. Okay? And my second function is f of x equals 4. Well, that's just f of x is y, so y equals 4. Well, y equals 4 is a horizontal line at 4. Okay, so you have this horizontal line at 4. But I have to know what part of the line I need. So where x is greater than 1. So when f of x, I plug in 1 for x, I still get 4 for y because that's my only option. So its starting point is 1, 4. Like my first function, the starting point was 1, 3. So it started at 1, 3. This is starting at 1, 4. Okay, so 1, 4. Notice that this is not an equal to. So that 1, 4, I'm going to put an open circle. Okay, so I'm going to have an open circle. And then I want where x is greater than. So that would be to the right. So all of this, I need to erase. So it had to be open there because it wouldn't be a function if not. So if this had been closed, then it would have failed vertical line test and not been a function. Okay. So one of those points had to be open. This one specified that the horizontal line was the one with the open circle. Something we should have done at the beginning is to put a scale on our graph, give it some meaning. So these are 10 by 10. So I like to put the scale out here, just so then it's not in the way. Okay. All right, this one has 3 pieces. All right. So my first one is f of x equals 0. So that's a horizontal line at 0. And then my starting point is -4. So -4, 0. Okay, I'm going to use an open circle because this does not have an equal to. -4, 0, open. And then it's where x is less than -4. So that would be to the left. So there's that first piece. Okay. The second piece, f of x equals -x. Okay? This one has 2 endpoints. I have an endpoint at -4 and an endpoint at 0. So, -4, I plug that in for x, then I get +4 for y. And then if I plug in 0 for x, I also get 0 for y. Okay, so -4, +4. And because of the equal to, it'll be a closed circle. And then at 0, 0, there will be an open circle. Okay, again, this is linear. So you could also think of it having a slope of -1 and a y-intercept of 0. Also, the negative out front of the function reflects it. So what I did was I took that parent function y equals x, and we reflected it over the y-axis with that negative out front. Okay, so I can use my transformations, but then I do need to cut off the points that are not being used. So this one has only here to here. Okay, then my final function, 1/2 x squared. All right, well, x squared is quadratic. And when I have a 1/2 out front, that represents a vertical shrink. So I'm taking my parent function, and I'm doing a vertical shrink. So I'm going half of the y coordinates because it's a vertical shrink. Or I can think about plugging in points, any points that are greater than or equal to 0. So let's start with 0. We need our endpoint. Okay, so that's 0. Okay, and then let's go greater than 0. So if I plug in 1, I get 1/2. If I plug in 2, 2 squared is 4 times 1/2 is 2. Let's do one more. I'm picking even numbers because those are easy to multiply by 1/2, so that's why I skipped 3 and went to 4. 4 squared is 16, and then 1/2 of that is 8. So at 0, 0, I have a closed circle. Well, I have an open circle, but I have a closed circle on top of it now. Okay? So there's a closed circle, and I'm going to show you how to write this, how to represent this here in just a minute. Okay, and then I have the point 1, 1/2, 2, 2, and then 4, 8. Okay. And it's for everything greater than or equal to 0, so I do need to include an arrow here. That's going to keep going on. So if you only have one inequality sign, like we do here, then I only have one endpoint. If I have two inequality signs, like I did here and here, then I have two endpoints. Okay. So how to write an open circle and a closed circle together? Well, the open circle goes with this linear function. Okay, so here's it's closed with my quadratic. And to show that it's open on top, you do this half arc. And the half arc needs to be connecting with the graph that it's supposed to. So if my open circle had been with a parabola, I would put my half arc here. Okay. Again, I need to remember to do my scale. I still just counted by ones. Okay. Next, we're going to talk about absolute value functions for a minute. Well, you know that absolute value is a V shape on your graph. Okay, and we know that by definition, whatever's inside of x can be positive or negative, and then when you take the absolute value, you get x. So it gives me this graph where I have this V shape. But really, absolute value is a piecewise linear function. Okay, where this right side has a positive x, and it's where x is greater than or equal to 0, so that's here. And the left side is the opposite, so negative x, it has a negative slope, and that's on the left side of that 0. Now, it has to be a function, so one of them has to have an equal to, but the other one cannot. So really, it has this arc here. They cannot both have equal to's, otherwise it would not be a function. It doesn't really matter which one has the equal to. We tend to just put it with the positive case. Okay. So let's talk about 0. So 0 here, where x is 0, is the break point of our graph. So that's where the graph switches from decreasing to increasing, or from the negative slope to the positive slope. So I'm going to call that our break point. It is a critical number because it's a break point. And let's look at that on a number line. Okay, so there's my break point. And anything, if I plug in for x, so anything left would be negative, anything right would be positive. So left of 0, where we're getting this, has a negative slope, okay, as I see here, right there, well, right here. And then anything right of 0, so that's greater than or equal to 0, has a positive slope. Okay, so right here, there's a positive. All right, so our goal when we rewrite these is to find that breakpoint and then determine the positive and the negative. So I'm taking absolute value and I'm writing it as a piecewise function of two linear functions. Okay. So f of x equals x plus 2, absolute value of x plus 2. All right, well, I want to find my critical value, which is my breakpoint. So the breakpoint is what you're taking the absolute value of equal to 0. Okay? So my breakpoint is negative 2. If I subtract 2, I get x is equal to negative 2. All right, so let's look at that on our number line. So this is for x plus 2. So if I plug in a number left of negative 2, so let's say negative 3. Well, negative 3 plus 2 is negative 1. Okay, so I'm doing the negative, the opposite of what I have. I would need the negative slope here. And then if I pick a number bigger, so let's say 0. Well, 0 plus 2, that's positive. Okay, so I want the positive slope for numbers greater than negative 2. Okay, so we're going to start writing out what we just had. So let's start with our domain with the inequality part first. Okay, so it's positive here. Okay, this side is where x is greater than negative 2. Okay, this side is less than negative 2, so that's x is less than negative 2. All right. One of these needs an equal to, so I'll put that there. Okay, so it's positive here, so you need the positive slope, so you're going to just get x plus 2. It's negative here, so you need the opposite, the negative slope. So you're doing the opposite of x plus 2. That's going to give you that left side of the graph. Okay, so this side here is a negative slope. This side here is a positive slope. Okay, I do need to simplify this a little bit. So this is x plus 2. X is greater than or equal to negative 2. So what I mean by simplify is distribute that negative. And there is my piecewise function. So the graph of this piecewise function and the graph of this absolute value function are the exact same. I'm just rewriting it in a different way. So instead of writing it as an absolute value function, I'm writing it as a piecewise function. Let's think about the transformation. So if it's an x plus 2, that means I shifted to the right 2, which is why my breakpoint is no longer at 0, but at negative 2. Okay. So your breakpoint will come from what's inside the absolute value, because that's the changes on x. So how x is changed is how you will find your breakpoint. Okay, let's look at this one. All right, I see that 3 plus out front. If I were to rewrite this, then I know that 3 at the end is just a vertical shift up 3. Okay? So I want to keep that in mind as I'm writing these. All right, let's find our breakpoint. So our breakpoint, it comes from the changes on x, which is just what's inside our absolute value. So I set out negative 2x plus 3 equals 0. So then I can find the changes from 0 of my breakpoint. So subtract 3, divide by negative 2, so positive 3 halves. So my breakpoint is 3 halves. Okay. So what I am plugging numbers into is this negative 2x plus 3, and then I'm determining whether I get positive or negative values, so I know if it's my positive or negative slope. So let's say I pick x equals 0. So if I plug in 0 for x here, and negative 2 times 0 plus 3 is negative. Oh, positive, sorry. Negative 2 times 0 plus 3 is 1, so is 3. Negative 2 times 0 is 0, plus 3 is 3, so that's positive. Okay. And then right, so 3 halves is 1 1/2, so let's say I plug in 2. Negative 2 times 2 is negative 4, plus 3, negative 1, so that's negative. Okay, so this time, I have a positive slope left. Okay, so that's going to look like this. And a negative slope right, so that's going to look like this. This is is just to help visualize. My answer is going to be writing the piecewise function. All right, so let's do our inequality part first. All right, so I'm positive here to the left of 3 halves. So that's here is less than 3 halves. Okay, less than or equal to. So positive case, we put the equal to part 2, usually. It doesn't really matter though. If you put it on the other one, that's fine. It just can't be on both. Okay, and then I'm the opposite. I have a negative slope here when x is greater than 3 halves. Okay, but it's the positive and negative of this. Positive and negative of that. So I have the positive, negative 2x plus 3, so nothing changes. Then I have the negative 2x plus 3. But remember, there was a vertical shift. Okay, but that's not affecting my x value. That's not affecting my break point or the positive and negative part. But it will affect what my function is at the end, because I still need this absolute value graph to go up 3 units, so that would change my linear equations a little bit too. Okay, so if I simplify, that's negative 2x, and then 3 plus 3 is 6. Okay, where x is less than or equal to 3 halves. Here, I distribute the negative, so that's positive 2x. And then I do, so negative 3 plus 3 is 0. So my linear functions would be these two, and that together is my piecewise function. Another way to think about the positive and negative part. So remember, inside absolute value, so inside this absolute value right here, I can have some plug something in and get a positive number and still get a positive out because it's absolute value. I can also have it equal to the negative and then still get a positive out. So that's why we have the positive 2x plus 3, this part, just this part right here, and the negative negative 2x plus 3. But that plus 3 is not affected. The plus 3 at the end is not affected because it's not inside the absolute value. All right. Okay, so homework. So your 1.3 homework, some of it's due Monday and some of it's due Tuesday. Okay, so the Pearson homework is due Monday. You can now do all of it, so I think there's 14 total, so 1 through 14. Then you need to do 1.3, page 175, 46, 52, 54 on graph paper, but you only need to do part A only of those. And then the 1.3 absolute value to piecewise worksheet, that's due Tuesday, and that's in the Schoology folder, the worksheets handouts in Chapter 1 Schoology folder. Please email me if you have any questions. You will have a work day on this tomorrow.